Hey class, we're going to be looking at how to add and subtract rational expressions in this video. If we have time, I'm going to also go over simplifying complex fractions, and then the application will have to come in a later video. So let's go. Let's do this. We're going to start pretty simple and add and subtract some fractions that you probably learned how to do in, I don't know what grade it is. 4th grade, 5th grade, 6th grade, somewhere in there. We're going to add 3/4 plus 2/3. What do you need to add fractions? You need a common denominator. So my least common denominator is, you're looking for a number that 4 and 3 go evenly into, and that would be, for this problem, 12. And you guys can probably just figure that out in your head. What you're doing is you're looking at all the multiples of 4, 8, 12, 16, etc., and all the multiples of 3, which are 3, 6, 9, 12, 15, etc., and the least common multiple is 12. So that's what you're really doing, but you probably just did it in your head. So what we need to do to get that common denominator is I have to multiply over here by 3 on the top and on the bottom, and over here by 4 on the top and on the bottom. So now we're going to take 3, we have a common denominator of 12, so we had to multiply on the left by 3 and on the right by 4. And then we end up with 9 over 12 plus 8 over 12. Now I have a common denominator, that stays my denominator, and then you just add the tops together. So 9 plus 8, which is 17. You can leave it like that. It's simplified. It's not in mixed fraction form, but it's perfectly fine to leave like that. 12 and 36, on the top one, we had to multiply the 4 times the 3 to get our least common denominator. But for the second one here, if you look at the multiples of 12, you have 12, 24, 36, 48. 12 goes evenly into 36. So if I start listing the factors of 36, it's 36, 72. The least common denominator between those two is 36. The least common multiple of 12 and 36 is 36. So that's going to be my denominator. This one's already got 36 for the denominator. But this over here has a 12, so I have to multiply by 3 on the top and on the bottom to make it into a denominator of 36. And then we're subtracting for this one. My denominator will be that least common denominator of 36. And then on the top, it's 15 minus 1, so 14 over 36. However, this is not simplified because 2 goes evenly into 14, and it goes evenly into 36 18 times. All right, so we're going to use the same kind of concept when we're adding and subtracting rational expressions. It might be... it'll be slightly different because we've got to look at multiples of expressions with variables in them. So here's an example. We've got 6x plus 5 divided by x squared minus 3 plus 3x minus 1 divided by 3x minus, or x squared minus 3. I'll just pause the video and write this down so that you can follow along and replay when you get it written down. Okay, so what we are going to do is we are adding fractions, so we need to have a common denominator. So in order to add any fractions, you need a common denominator. And if you notice, these guys have a common denominator already of x squared minus 3. So that is going to be my denominator. I'm starting out relatively easy, and they build, so bear with me here. But we have that common denominator, so we just leave it, and then we add the tops together, so we have 6x plus 5 right from here, and then plus 3x minus 1. Simplify the top. You can combine your like terms. That's 9x, and 5 minus 1 is 4, so 9x plus 4 over x squared minus 3, and that is your expression after being added. And there's nothing to simplify there. Okay, but I gave you a problem there that had a common denominator already. not going to always be the case. So what you need to do is we're going to look at, first of all, how to find the least common multiple of polynomials, which is going to end up actually being our least common denominator when we end up with rational expressions. But here's how you do this. Okay, so to find the least common multiple of polynomials, step 1, pause the video, write this down in your notes. You're going to first want to factor each polynomial completely, and then any repeated factors, write those as powers. So for example, when I factor this polynomial x cubed plus 6x squared plus 9x, first thing you look for when you're factoring is, are there any common factors? Which there is. There's an x that shows up in all of them. So I'm going to factor out an x. And what's left inside would be x squared plus 6x plus 9. Now I have a trinomial. Let's keep factoring. This is going to factor into x, and then look for factors of 9. Add to positive 6, it's x plus 3 and x plus 3. So I have a repeated factor of x plus 3. So this, in factored form, but with the repeated factors written as powers, would be, it's going to be x times x plus 3 quantity squared. So this is factored form of this original expression. Okay, then for step 2, what you want to do is list the different factors. If the polynomials have common factors, use the highest power of each common factor. Highest power. So make sure that you realize you want to take the highest power of each of the factors. All right, so get that written in your notes. So here's an example. Find the least common multiple of 4x cubed and y to the 4th, and with 12x to the 5th, y to the 4th. So we're going to write this, we're going to factor this. 4, so you can do a factor tree. It's 2 and 2, for the, at least for the number part of it. And for 12, it's 2 and 6. You're going to factor to primes, which these are prime. And then I have 2 and 6 keeps, you can factor that into 2 and 3, those are prime. So if I'm going to write this in factored form, it's 2 squared, because I have 2 times 2, x to the 3rd, y to the 4th. Those are already written with their powers. And then for the second one here, it's 2 squared, I got 2 and 2, times 3, times x to the 5th, times y to the 4th. And so now, going back here, we're going to list the different factors, which we just did. If the polynomials have common factors, use the highest power of each common factor. So the highest power, for my least common multiple, the highest power of 2, look at both of these expressions, is 2 squared. Then you have a 3 over here to the 1st. That's the highest power in either expression, so that's going to be part of my denominator, or I mean my least common multiple. I've got an x cubed over here, and I got an x to the 5th. The highest power is x to the 5th. And then I have a y to the 4th and a y to the 4th, so the highest power in either expression is y to the 4th. This is my least common multiple. 2 squared is 4, 4 times 3 is 12, 12x to the 5th, y to the 4th is the least common multiple between those two terms. And if you think about it just kind of logically, you've got 4 and 12, and the least common multiple of 4 and 12 would be 12, because 4 goes evenly into 12, and 12 also goes into itself once. X to the 3rd, you got x times x times x. X to the 5th, there's 5 x's. You got what's common to both is x to the 3rd, but what shows up in both, or you've got an x to the 5th, and that's the highest power of that factor, and then y to the 4th is the highest power of the other. Okay, so here's another example. Let's look at this example where you have x squared minus 4, and we're going to factor that. X squared minus 4 factors in, is a difference of squares, so factors in x minus 2 and x plus 2. And then this other, so that's that expression. So we're finding the least common multiple of x squared minus 4, And then this expression, x squared plus 5x plus 6, so let's factor it. It's x, and factors of 6 that add to 5 are going to be x plus 2 and x plus 3. Okay, so the least common multiple. All of the factors that show up in either one have to be in our least common multiple. So I need an x from over here. I need an x minus 2. And I've got x plus 2. Going to the other expression, you've got x plus 2 to the first in both of these, and the highest power is x plus 2 to the first. I don't need to multiply by another x plus 2 because it's already here. But I don't have this factor, x plus 3 to the first. So my least common multiple would be x minus 2 times x plus 2 times x plus 3. Okay, so this time we're going to do an example where we find the least common multiple of the denominators, which is, another way to say that is the least common denominator. And then we're going to add the expressions. So we need to find that common denominator in order to add the fractions. So on the left, we have x over x plus 3. On the right, that's completely factored, both the top and the bottom. In the second expression, I have 2x plus 6 over x squared plus 6x plus 9. So for my least common denominator, I need to have this factor show up. But then I also need to look at this guy over here, and I need to, what I want to do is factor it. It's x plus x and factors of 9 that add to 6, plus 3 and plus 3, which can be written as x plus 3 quantity squared. So I have an x plus 3 over here, but I have an x plus 3 squared over here. The highest power is x plus 3 squared. So my least common denominator is x plus 3 squared. So I'm going to erase this, make it a little bit neater here. This is my common denominator. Let me rewrite this. I have x times x plus 3 and then plus 2x plus 6 times x plus 3 squared. So the least common denominator, we already have it on the right side, but I have only one x plus 3 on this side, so what do I have to multiply by to make it x plus 3 squared? Hopefully you're seeing it would be another x plus 3 to make it x plus 3 squared. If I do that on the bottom in the denominator, I also have to do that in the numerator. So then what I'm going to do from there is I'm going to distribute x, x squared plus 3x in the numerator, and then in the denominator, x plus 3 times x plus 3 is x plus 3 squared, plus over here on the right side I have 2x plus 6 over x plus 3 squared. So now I've created a common denominator, and that's going to stay my denominator, and then we're going to add the top. So x squared plus 3x plus, so this plus, we're going to add 2x plus 6. And it's just addition, so you don't need to have those expressions on the left and on the right in parentheses. You can just write them straight across. And then we're going to combine our like terms. So we have x squared, 3x and 2x is 5x, plus 6 over x plus 3 quantity squared. Now this one's a little tricky because it actually still can simplify, because remember x squared plus 5x plus 6 factors into x plus 2 and x plus 3. And I have x plus 3 squared down here, which means x plus 3 times x plus 3. And you can simplify this, and it becomes, after all the simplifying, x plus 2 divided by x plus 3. And that would be your final simplified answer. So this would be undefined at x equals -3, because that would make the denominator equal 0. Okay, so I'm going to stop here, and I'm going to make a second video with some more examples of how to add and subtract, and then I'm also going to do some subtraction.